Oh boy, it's TC Does Something Electrical time again. Today, we are answering the age-old question, why do US plugs have holes in them? That's a great question, and many people have asked that, especially people who have noticed that plugs have holes in them. Let's ask everyone's begrudgingly favorite search engine. Oh, that's a perfectly logical explanation. Of course, why didn't I think of that? The outlet side must have some sort of squeezy thing to grab the blades of the plug, and putting a little hole in the plug for it to index to sure would be helpful. I bet that makes the plug less likely to fall out of the receptacle. Except it doesn't, and that's not what it's for. At least, not intentionally. While the commonly cited explanation makes logical sense, it seems few people are taking the next step, which is of course to test this claim. And no, you don't need to do what I'm about to do and rip an outlet apart to see its insides. That's dangerous, and you should not do that. But what you absolutely can do, and probably have done several times in your life, is plug something in and pay attention. Now, as I've said many times at this point, the NEMA plug design that we are stuck with here is objectively terrible and among the worst in the world in terms of safety. Just a friendly reminder that this pin is live and yet really easy to touch, but we've been over that. What I want you to notice is what it feels like when you insert the plug. Here we have a standard polarized lamp cord. Oh, right. Side note, there is one thing that our plug does to try and make up for its general haphazardness. I haven't brought it up because I assumed it was fairly universal across the globe, but much to my surprise it isn't apparently. Our plugs are polarized. Look at practically any outlet and you'll see that one of the slots is wider than the other. And on many 2-pin plugs like this, one blade is fittingly wider than the other, meaning it can only be inserted into the receptacle one way. This is to enforce polarity between live and neutral. Of course, this only works if the receptacle was wired correctly, but assuming it was, the narrow blade is live and the wider blade is neutral. Grounded plugs usually don't bother making the neutral blade wider because the position and presence of the ground pin enforces polarity on its own, similar to how many other countries do it. You might think that since we're dealing with AC power here, polarity doesn't matter. And yeah, everything will work if it's wired backwards, but that introduces danger in certain situations. Take, for example, an antique toaster with a single pull switch. If polarity isn't enforced in the plug and the switch happens to be on the neutral side when you plug it in, then all of the heating elements and bus bars that are literally right there and in easy reach would be live at 120 volts even when the toaster isn't toasting. That's shockingly unpleasant. A simpler but no less important use for a polarized plug is in a common lamp with an Edison socket. These are dangerous all the time because child fingers, and indeed full-size human fingers, can get right in there. But making sure that the outer sleeve is neutral makes it at least marginally safer, and ideally prevents you from getting zapped off a light bulb where a bit of the screw surface is exposed, and that's pretty common. Still need the outlet and lamp to be wired correctly though, so don't go testing that one for yourself. Anyway, not everything needs a polarized plug. Things that are double insulated, for instance, pose very little risk of leakage current happening, and so either blade is free to be whatever it wants to be. As an example, tons of electronic stuff like USB power supplies, or other power supplies, don't bother with polarization. But most general electrical devices, especially those with a power switch, will use a polarized plug to ensure the switched leg is the hot leg. It's one of the few objectively good ideas in this plug design, and oddly enough we all seem used to it and aren't constantly playing Schrodinger's USB. Of course, we could just put a ground pin on everything, but where's the fun in that? Then these things wouldn't just be dangerous, they'd be useless. Okay, so back to the holes. I've got a lamp here with a Holey plug, and you know what I'm going to do? I'm going to plug it in. Slowly. If these holes are used as a point for some sort of mechanical pinchy dude to grab on, surely I should feel the plug sort of give as it's fully inserted, right? That would be when the holes would align with whatever this pinchy thing is. At least you'd hope so. Okay, so here we go. There doesn't seem to be any sort of change in resistance here. It's just a firm but smooth push the whole way. Same with removal. But I've got a bunch of different outlets I can test. I've got more of these than any other because I'm fancy, but here's a tamper-resistant GFCI outlet. Same as before. Alright, and another one with a switch built in. Still no obvious interaction with those holes. Alright, here's a more generic one in my garage. Nope, still smooth. The basement. There's more in the basement. There's this GFCI receptacle here by the electric panel, and nope, nothing. This one over here. Nope. Okay, but there's these. The gray tamper-resistant ones on a switch, by the way. I knew you'd want to know. Nothing on the white one. Okay, the gray one. Help me out, the gray one. You're my only hope. No! Is there not a purpose for these holes? Has my life been a lie? Oh wait, there's a 20 amp GFCI in the garage I forgot about. Here goes. At last, the plug gave way after I first encountered resistance. Something's engaged with the holes. But wait, that's not inserted fully. Well, that's silly. Indeed it is. So was that whole sequence. Anyway, to see what's going on, we need to look at what's inside some receptacles. Luckily, through the magic of buying several and viciously tearing their faces off, we can see. I have 4 different kinds today. The cheap kind that comes in a big old box with like 100 of them just loosely thrown around. A slightly less cheap one that purports to be heavy duty. A so-called commercial grade feller. And this one that's old, and I have a bunch of them, and I couldn't really tell you why exactly. They're off-white. Not my jam. I suppose mayonnaise is an off-white jam. So, these are the grabby things. They actually grab onto the plug's blades and make electrical contact with them. And they're all different. Luckily, we can remove these from the plastic to get a closer look at them. Of these designs, there are 2 that might sort of make use of those holes, but let's start with the 2 that obviously don't. That's these 2, the mystery one and the cheap one. In the cheap one, we have 2 perfectly flat brass pieces pressing into each other. There isn't any kind of protrusion or bump or anything to even hope to engage with the hole. And indeed, the hole will simply glide right on through. In fact, the flat surfaces are longer than the hole's diameter, so there's no possible way for the hole to have any sort of impact. This is purely a friction fit. With the old mystery one, we have the same deal, although the construction is a little different. Here, the brass is formed into a U shape, and the blade goes in the middle of the U. Now the blade is wider than that gap, so there is quite a lot of friction produced here, but it is notable that in the other design, the blades actually touch without a plug in place. It's a very different design here, with the spring tension being delivered from this lower joint and not the U-bend. Perhaps it's more durable, but I'm not about to sit here for months and find out. So now the heavy-duty one. This is a little strange. We have a somewhat similar arrangement to the cheap one, with 2 angled tabs meeting to form a pinch point, but the brass pieces aren't straight. One is very slightly curved, and the other also deviates slightly from straight to meet it. With a blade between them, the resulting deformation gives 2 not quite flat contact areas on either side of the blade. Now, this kink spot here seems to sometimes land in the hole. Without a plug in place, you can see that the 2 sides actually only touch at the top, almost making a tent shape. Sadly, I did not buy 2 of these, a terrible oversight on my part, so I can't see how the plug fits in here, and its face is too mangled to get an accurate idea. But I have to say that of these designs, this one seems to be the absolute worst. The width of a plug's blades isn't enough to deform these into straight parallel lines. They're simply too far apart, so you don't get a flat contact patch with the blade on either side. Instead, you get 2 smallish points. Don't like that. But because of that, depending on how you insert the plug, those points might land where the hole is and sort of grab onto it. But I sincerely don't think that's intentional. In fact, if that happens, you'd get an even worse electrical connection because there'd be less pressure on the blades where the hole is. And so now we are down to the commercial version. This one's got weird-looking sideways blade grabbers because this same design is used in 20 amp receptacles, and likely the even weirder-looking NEMA 615 and 620R 240-volt receptacles. Yes, friendly reminder, 240-volt circuits exist here, but they're weird. I made a video about them. Anyway, the actual contacts are able to accept either the normal vertical blade or the less normal sideways ones, and that's why they look like this. Taking a closer look, we can see that, once again, there's nothing in there that looks as if it's intentionally engaging with the hole in the plug. The inboard contact is completely flat, with nothing so much as a bump, and the side contacts, well, maybe they might drop into the hole a bit, I suppose, but again, doesn't look to be intentional at all. And if we go back to this here outlet, which undoubtedly has the same internal connections, at least on the left-hand side, we'll remember that while the plug does seem to get caught as it's inserted, that happens before it's fully inserted, which is just silly. The fact of the matter is, this is just a friction fit. That's it. The presence of the hole in the plug, if anything, makes the connection slightly worse. But here's the thing. If a plug is fully inserted, those holes end up way past the actual point of contact. And you don't even need to look in here to see that. Just grab a plug. After a few insertions and removals, there will probably be witness marks left on the blades. And sure enough, they don't stop at the hole. They go well beyond it. One of the other holes in this hole argument is that lots of plugs don't even have them. This timer doesn't. And this is the only thing I could immediately find. But I can think of at least two other unholy things I've had: a nightlight and a lamp. Also, I'm pretty sure I have a power supply cord somewhere without holes. Also, it should be noted, this is from IKEA. It's not just some weird random timer from the dollar store or whatever. Despite not having holes in its plug blades, it fits just fine into all my outlets and whatever. Nice and snug. So what's the deal with the holes then? Why do so many, in fact nearly all, plugs have these holes in the exact same places if they're not actually doing anything useful? Well, the toads over at NEMA actually do tell us what the deal is with the holes. The holes are, and I quote, optional, and it is intended for manufacturing purposes only. However, if used, it must be located as per dimensions shown above. Interesting. You know, manufacturing purposes makes a lot of sense now that I think about it. Take this incredibly common plug design. The leads of the cord are simply soldered or perhaps crimped to the blades, and then a big old glob of plastic is molded around it. These clear ones reveal that quite clearly. Putting holes in the blade would allow for a very simple mold alignment procedure using nothing but some sort of stick. In fact, here's that exact thing happening in a factory which manufactures these. The worker simply has to thread an alignment rod through this holder, place the blades and wires in there while pushing the rod through as they go, give a tug to ensure it's aligned, and boom, plugs made to spec. But why is the location so important? Well, as far as I can tell, the answer appears to be pretty simple. NEMA just wants to be sure that the hole is far forward enough that it won't land where the contacts touch the blade when the plug is fully inserted. We saw from the witness marks that the hole should go past the contacts, and none of these receptacles engage with the hole in any deliberate manner, and those which appear to do it badly. Again, this is not fully inserted. While editing this video, I ran across some mention of old patents which do show using the hole as part of a locating mechanism. I didn't confirm these, but another person claimed to have seen some old receptacles in the wild which had a locking lever, presumably utilizing those holes. However, it seems pretty clear that these are long deprecated uses for them. Whether NEMA is honoring these legacy devices in codifying the location of the holes is not known to me, but I guess it's possible. However, I think in the end, it's not a good idea to encourage contact designs which use the holes for indexing because of a problem I'm about to bring up. Now, I suppose there could be receptacle designs out there which do have some sort of bump on the contacts which indexes the hole, but that seems like it would introduce other problems. If that were the case, the pins would have to bend beyond their resting point to allow for plug insertion, and they'd wear out more quickly. At least it seems that way to me. Maybe there was an old design that NEMA wants to ensure compatibility with, but that still seems unlikely to me. All signs seem to point to it just needs to be at least this far forward, and also making it too large would affect structural integrity and current carrying ability if the plug weren't fully seated, so we codified the hole's size and position. Whether you want to use it and for what is up to you. Well, I think that's about it. This video has a lot of speculation in it, if you couldn't tell, but I'd welcome any of the nematodes out there to fill us in on any details I might have missed. Like, for instance, are there historical designs out there that use these holes for something? And why is it so common for devices to have them? Even things like these. Is there a factory somewhere that just makes zillions of these blades and they put the holes in not knowing what they're going to be used in? Will I ever stop asking questions? Yes, though I have to wonder if part of their prevalence comes from people feeling that they just need to be there. I'll admit that the rare plugs I find without holes all seem kind of wrong. And so maybe this is just a huge cultural or manufacturing inertia thing we've slipped into somehow. People have seen the holes, and so when speccing out whatever thing they want to manufacture, they just put them there. Or maybe there is a factory that just pumps out these blades day in and day out, so it's not even easy to get a solid blade. In the end, though, it doesn't really matter. This is a pretty silly video, huh? Oh, but before I go, I want to push back on a very common sentiment that the rest of the world has about our plugs. I've seen over and over again this notion that they don't stay put, that plugs will just fall out of the wall. I can assure you that I absolutely think our plugs are flawed in myriad ways, but this isn't really that common. Sure, receptacles will wear out with time, and actually, if you have one in your home that barely holds onto a plug, you really ought to get that replaced because that can lead to fires by way of poor connections and high resistance. But it typically takes decades for a receptacle to wear to that point. Most outlets require a firm pulling force to unplug things, and big nasty wall warts don't have trouble hanging on. However, not all receptacles are created equal, and I think a big part of this perception can be traced to the worlds of hotels, airplanes, airports, travel. And in particular, this style of receptacle, the kind that often gets integrated into bedside lamps. I tried looking for something in the hardware store that had this so I could take it apart, but I couldn't find one. That's why this is at the end. But I suspect that these are made to much lower standards than the equipment that actually gets placed in a wall. I myself have encountered plenty of outlets like these that are barely holding on to something I've plugged in, and many are so damaged they don't even work anymore. But it has been quite rare that a real duplex outlet has this issue, at least not to that extreme. Now, even if this weren't a bad design, there's the simple fact that in a travel scenario, something's getting plugged into those outlets far more frequently than is typical. There's a finite lifespan on any connector, and in a setting where people are going to be using them daily or perhaps more frequently than that, they're going to wear out quickly. In a home setting, many outlets get used maybe weekly. Some have something get plugged into them and then aren't touched for a decade or more. Anyway, I'm just bringing this up because this criticism is really quite situational. Every time I hear it, I'm like, no, that's not a thing I deal with. But then I remember that actually, yes, in hotels, that's quite common in my experience. And so I think a lot of you are experiencing badly designed, worn-out receptacles, and then assuming that's the norm. And I feel that I must, on behalf of my NEMA compatriots, inform you that this is incorrect. But yeah, it's still a pretty bad design all around. The mere fact that this is possible is unforgivable, just tremendously bad. Oh well, at least it's not 240 volts coming out of there. Let's ask everybody's favorite begrudgingly well, we were doing so well. Especially people who have meaning it can only be inserted into the receptacle. I don't like how that went. This only works if the receptacle was white. Yeah, I'm gonna start over because I misread that and I don't want to faff with that later. The cheap kind that comes in a big box with 100 or so just Los Oops. Nima just wants to be sure that the hole is far forward enough that it won't land where the contacts touch the blade. Sentence wasn't over. It's like when you insert the plug. Here we have a standard